All right, everyone, we're back to start section 3. Section 3 is actually going to be a fairly quick unit because it's more about interpreting the diagrams and being able to read the chart than it is about adding too many more concepts to it. But one of the things that we want to be able to identify and characterize are the proper names for each phase change, and to correctly interpret phase diagrams. Phase diagrams are just what they sound like. We want to look at each phase of matter, solid, liquid, and gas, and be able to tell when a substance is at a solid, a liquid, or a gas based on temperature and pressure. Define again and apply the terms listed below, which majority of these are your phase changes. So you'll be able to keep those in mind. Some of them we've talked about, some of them we still got to go. But let's get started. Now, a phase change in general is, again, just looking at what happens to the molecules as we go from one state to the next, as we go from a solid to a liquid to a gas, or a gas back to a solid, or different things like that. Some of the basic ones that we've dealt with thus far for the states of matter are solid to liquid, being melting, liquid to gas, vaporization, liquid to solid, freezing, gas to liquid, condensation. Now, the two that are brand new in this case are actually going to be sublimation, which some of you may have known already, and others it may be brand new. But this is the process where a solid turns directly into a gas without going to a liquid first. One of the good examples for this would be the use of dry ice. Second, the process of where a substance goes directly from a gas to a solid, and this is a very rare one. I have yet to see this one other than in video form, but it's called deposition. So it's saying like it deposits from a gas directly into a solid on a surface or a substance. So here we have our common and proper names for each of our phase changes. Now we'll utilize this as we look at our diagrams. Now, phase diagrams are a diagram used to illustrate the conditions of temperature and pressure where a substance exists as a solid, liquid, or gas. So as we look at the diagram, we notice that we have the three colors, the three different sections for our solid, liquid, and gas. Our temperature is across our x-axis, and our pressure is on our y-axis, given in kilopascals. Now, in terms of normal melting point, normal boiling point, again, these are going to be the points where we are at what is called a normal or regular atmospheric pressure, which is about 101.3 kilopascals, or 1 atmosphere. So let's take a look at these couple of different things. Now, if you notice, we have here in our diagram, we have what's called the triple point. The triple point is given right here at the bottom of the diagram. Now, this is going to be the point where all three phases exist in equilibrium with each other. This is actually something that's kind of cool to see with water. If you have it in a flask, you have a slight frozen area, but you also have the vapor and the liquid sloshing around. It looks kind of cool. Let's see if I can't get one set up for you, or at least give you an opportunity to see it. Now, as the temperature is raised, we notice that our chance at having a solid decreases greatly until we look at a couple of other factors. Also, as the pressure increases in some of these areas, we're going to notice that our ability to hold on as a liquid, or whether it will change directly into a gas, will be affected. When we talked about before our gases, and we're going to come back to those in the next part of our unit, we looked at the fact that if we want a gas to behave ideally, we have to keep our pressures very low, and we have to keep our temperatures very high, allowing them the opportunity to move. This is what you're seeing here on the right side of the graph. This vapor phase, you notice it goes all the way in till we get to a temperature of 0 and even a little bit below. The lower it is, the slower the molecules are moving. If those molecules are moving slow, we have a higher chance that they're going to end up in that range as a liquid, which in this case we don't want. Now, at the top, or towards the top, it isn't really listed, but towards the top, right up here, we have what's called the critical point. This is going to be the highest point at which a liquid can actually exist. You notice after that point, the line disappears and we just have vapor and liquid, but they really actually form into one. this temperature and pressure will change again for each substance. So don't think that every diagram will look exactly the same. We just want to make sure you have the ability to look at it and to interpret the information on it. But looking at this information, we can tell for, say in this case, water, if I have this temperature and set pressure, which state should I find water in? How can I use this? Now, this ends up our unit for our section 3 portion of this unit. Go ahead, make sure you have your notes and everything filled in. Be ready to go through examples when we come into class tomorrow. Have a great day.